This lecture is about probability. So we start probability from lecture 8. So this is lecture 8 of our course. So before we learn the probability, we should know that the sample space. What is a sample space? When we count or do an experiment, the collection of all possible outcomes which can happen is called a sample space. So when you do some experiment, everything that can happen is called a sample space. If you collect all possible outcomes, that is called a sample space. Okay, so such examples, if we toss a coin, so that is an experiment. Tossing coin is an experiment. The possible events or outcomes that can happen is either head or tail. So the sample space is head and tail. So this is the sample space because only these things can happen when you toss a coin, right? Either head or tail. Now, tossing two coins at a time. When you toss two coins at a time, then you can have either both head. So we write H and H for head and head. Head and tail. Tail and head. And tail and tail. Okay, so these are the all possible outcomes when you toss two coins at a time. So when you toss one coin, you can either get a head or a tail, right? But when you toss two coins, you can have head and head, head and tail. You can have tail and head, and then tail and tail, right? So these are the all possible outcomes. So when you put these all together, then it makes a set, it makes a collection, and that collection is the sample space. Tossing three coins at a time. When you toss three coins at a time, head, 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 you can have two head and one tail. You can get head, tail, and head. You can get head and tail and tail. Or you can get the first coin tail and then the other two head. Tail, head, tail, tail, tail and head, and tail, tail, tail. Okay, so these are the possible outcomes when you toss three coins at a time. See, all these are different because getting all three head and getting all three tails, these are different. Getting two tails and head, getting two tails and head, but in different order. In different order means you get the first coin tail, the second head, and third tail is different from the first two coins getting tail, and then the third getting head. Okay, so these are considered different outcomes. So when you toss three coins, you get these many outcomes which are different from each other. And this is all total of 8 possible outcomes you get when you toss three coins at a time. Okay, so when you toss a single coin, you get 2 possible outcomes. When you toss 2 coins at a time, you get 4 possible outcomes. And when you toss 3 coins at a time, you get 8 possible outcomes. Okay, similarly we can have tossing 4 coins and 5 coins. We will get the higher number of outcomes. Okay, so for these examples it is not we don't discuss that 4 or 5 coins. Now the next example is rolling a die of 6 face. You know the dice, right? So it has a 6 face in that dice. So when you roll a single die, then the sample space is you can have 1 or 2 or 3 or 4 or 5 or 6, because one dice has See, the dice has 6 faces, right? So you have 1 and 2 and 3. So you have these dice. So when you roll one dice, how many possible outcomes you may get? You may get 6 possible outcomes. Either you will get a 1, or you get a 2, or 3, or 4, or 5, or 6. So this is rolling a die of 6 face. Rolling 2 dice of 6 face. Okay, when you do 2 dice, then you get many possible outcomes. You can have 1 in one and 2 in another. You can have 2 in one and 3 in another. You can have 3 in one and 5 in another. So you'll have a large number of collections. So what are those collections? What are those outcomes? So if you put all these together, so what type of sample space we get? When you roll 2 dice of 6 face at a time, right? So let's see. So we get what? We get, let's put this bracket. This bracket indicates that we put everything in one place. You can have 1 1, you can have 1 2, you can put a comma in there if you like. 1 1 1 2 1 3 1 4 1 5 1 6. So this is not 11 12 13 14 15. Okay, so this is 1 and 1, 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6. When you have 2 dice, okay, so you have 2 dice here. Like you can have 1 in here, and you can have other. So you get 1 on top, and in another dice, 2. Okay. Okay. So you get 1 and 2, right? So you get 1 and 2 in this case. Likewise, you can have 1 and 3, 1 and 1, 1 and 2, 1 and 5, 1 and 6. So these are the possible outcomes when you have 1 in the first one, and you can have 1, 2, or 3, or 4, or 5, or 6 in the second one. So you can have 2 and 1, you can have 2 and 2, you can have 2 and 3, 2 4, 2 5, 2 6, 3 1, 3 2, 3 3, 3 4, 3 5, 3 6. Okay, 4 1, 4 2, 4 3, 4 4, 4 5, 4 6, 5 1, 5 2, 5 3, 5 4, 5 5, 5 6, and 6 1, 6 2, 6 3, 6 4, 6 5, 6 6. Okay, so these are the possible. Yes. Okay, so these are the possible total possible outcomes when you toss 2 coins, two dice at a time. You get 36 possible cases. You can have 1 in 1, 1 in 2, 1 in 3, 1 4, 1 5, 1 6, or you can have 2 in this one and 1 in this. So 2 1, and then 2 2, and then 2 3, 2 4, 2 5. So you can have this many possible cases. Okay, so these are all possible cases when you roll 2 dice at a time. So we get 36 possible outcomes. Birth order gender for 2 children in a family. So you can have they can have a boy and boy, boy girl, or girl boy, and girl girl. So these are the 4 total possible outcomes if we consider the birth order gender for 2 children in a family. So this is the sample space. Okay, find the sample space if a student attempts 3 questions to solve and gets complete or incomplete grades. Make a tree diagram. Now, getting a sample space by drawing a tree diagram. to obtain the sample space. So let's draw a tree diagram for this experiment. A student attempts 3 questions and then gets complete or incomplete grade. Okay, so the first attempt in the tree diagram, you can draw like the first attempt has 2 possible outcomes for the first attempt. Either the student gets a complete grade or incomplete grade, right? So this is the first attempt. Now in the second attempt, if it was a complete in the first one, then there is a 2 possible cases for the second attempt, right? So either it's complete for the second question. This was the first question. Okay, so solving first question, complete or incomplete. Now second question has 2 possible options. If it was a complete, the first question was complete, then the second question can be complete or incomplete, right? So it can be complete or incomplete. Or in the first case, if it was incomplete, then in the second question it can be complete or incomplete. So when you get into the second question, then there are these 4 possible cases, because if you get complete first question, you get these 2, one of these 2, and if you get incomplete this first question, you'll get one of these 2. Okay, now this was for the second question. Now for the third question, if you are in this case, you can have 2 more cases for the third attempt. It can be complete or incomplete. From here too, you get the 2 possible cases. Either it is a complete third question or incomplete. So likewise, you have in all of these cases, you get either complete case for the third question. Remember, this is for third question options, right? So for third question, so whatever the place you were in the second, you still have complete or incomplete. So complete, incomplete. And from here, you'll get 2 cases. Like you can have a complete third question or incomplete third question grade. Okay, so what is the sample space? Now when you look at this case only, now for this case you get what? You get complete. No, let's start in here. You get complete, complete and complete, right? So this was, you get all 3 complete. So this is one possible case. For this one, you have complete, complete and incomplete, right? So C, I. Complete, complete, incomplete. So first question complete, second question complete, and third question incomplete. Now if you are in this one, you get complete and then incomplete and then complete. So C, I, C. So this is C, I, right? And this is now incomplete. So this is like if you are in this case, you are in this one, and in this one. So you are in this category, right? So you are in incomplete category, incomplete first question, complete second question, and complete third question. So I, C, C. So this is I, C, I. This is I, C, and this is I. Okay, so this is the sample space. This total thing is the sample space for this experiment. Like in the same way, we get these sample spaces. So we get head, tail, head, tail, head, tail. So this sample space, if you want to draw the tree diagram, you will get exactly like this. Okay, so we get these sample space when the student attempt 3 questions and gets complete or incomplete grade. Okay, so this is the sample space. This is the sample space. Okay. Question 2. A student is taking 2 courses which need to pass or fail during the summer. What is the sample space for the student? Okay, so PPFF, no. PPPFFF, no. So if he takes 2 courses that has to be either pass or fail, then you can have PP or both pass and fail and pass, fail and fail. So this is the right answer. Okay, so this is the sample space for that experiment, like either passing or failing the summer course. Okay, now draw tree diagram again, like this tree diagram, to obtain a sample space in an experiment of tossing a coin and then rolling a die of 6 pairs. So first what it does tossing a coin. Okay, and then it does rolling a die. So when someone toss a coin, how many possible cases you get? You can have, like this is tossing coin. Okay, when tossing coin can have head or tail, right? So it can have head or tail. Now when it does rolling a die, now the second experiment is rolling die. Rolling a die. Then you can have 6 possible cases. So you can have 1, 2, 3, 4, 5, 6. Okay, so you can get either 1 or 2 or 3 or 4 or 5 or 6. Similarly, if you get a tail in the first tossing coin, then you can get 1, 2, 3, 4, 5, 6. So you can have 1, 2, 3, 4, 5 or 6. Okay, so you get, for this experiment, you get head and 1. For this you get head and 2. For this case you get head and 3. For this case, for this result, you get head and 4. For this result you get head and 5. For this you get head and 6. Now this one you get tail and 1, T2, T3, T4, and then you get T and 5, and you get T and 6, right? So the sample space is, equals to, now you can put it like this: head 1, head 2, head and 3, head and 4, head and 5, head and 6, tail and 1, tail and 2, tail and 3, tail and 4, tail and 5, tail and 6. Okay, so this is the sample space for this experiment. So you toss a coin and then roll a die. So you first toss coin, so you do first head and tail, and then you get 1, 2, 3 to 6. Event is a subset of a sample space corresponding to a particular outcome or a group of possible outcomes. Example, getting exactly 2 head while tossing 3 coins. Is while tossing 3 coins, this is the total sample space, right? So while tossing 2 coins, this is the total sample space. Now what is the event of getting 2 head? So this is getting 2 heads. This also 2, and these. So these 3 cases, these are the subset of the sample space. That is called the subset of a sample space is called an event. Okay, so what event is that? So getting exactly 2 head is this event. Okay, so let's see, the next page is, now in the next page we have the definition of probability, and this is the classical definition, theoretical definition. Probability of any event, let's put the name of event A. Probability of an event A equals to number of ways A can occur. So how many possible ways A can occur divided by the total number of outcome in the sample space. So now in the sample space, if you have 8 possible outcomes, and if you get an event of 3 possible outcomes, we divide 3 by 8, 3 out of 8. Okay, so that's how we get the probability. So how many possible event for the how many possible cases for that event divided by the total number of event, total number of possible outcomes. And here are some notes. Probability must be in between 0 and 1. So when you solve any probability question, you cannot have any answer which are negative numbers, because it can be 0 less than 0. It can be 0, but it can't be less than 0. So it can't be negative number. Probability can't be negative. The least probability is 0%, and the highest probability is 100%. So we have the probability between 0 and 1. So we can have 0.5, 0.4, any number, 0.45, 0.62, but it can't be greater than 1. It can't be 1.5 or 1.2 like that. Okay. Total probability is always 1. So when you add all probability, you get 1, which is 100%. 0 probability means the event can't happen. So when something can't happen, it has a 0% chance. So it is a 0 probability. 1 probability means the event is sure to happen, because 1 represents 100%. 1 represents 100%. So when it is a 1 probability, that means it is a 100% probability. So 100% probability means it's a sure to happen. Question 4. Let's see. Here now it says, if a fair coin is tossed 3 times, what is the probability of getting 2 or more tails? Now remember that when you toss a coin 3 times, you get that sample space. So I'm writing for this question, but you can write that sample space in a scratch paper, and you can find out the answers. You only need to write the answers. You don't need to write all sample space for probability questions, but I'm writing here just to explain you. See, for this question, if a fair coin is tossed 3 times, I get head, head and head. So this is the sample space. Sample space is HHH, HHT, HHT. Okay, so there is not comma in there. Here is the comma. Okay, so head, head, tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, and tail, tail, tail. Okay, so this is the sample space, right? Now this is the sample space. Now, what is the probability? Question is what? Question is, what is the probability of getting 2 or more tail? Now you choose how many are 2 or more tail. This is not 2 and more tail. This is not 2 and more tail. This is 2 tail. So this is 2 and more tail. This is 1. Right? This is 1. This is 2 and more tail. And this is 2 and more tail. So how many cases we get for 2 or more tails? We get 4. So the probability of 2 or more tail equals to 1, 2, 3, 4. 4 out of 8. 4 out of 8 is, you can divide by 4 to both up and down. So you get 1 out of 2. So 1/2 is the probability. You can write in decimal, it doesn't matter. You can write in fraction or you can write in decimal. 1/2, if you change into decimal, you get 0.5. So the probability is 0.5 or the probability is 1/2 for the getting 2 or more tail when you toss 3 coins at a time. Okay, now the next question is, what is the probability of getting exactly 1 head while tossing 2 coins? Now when you're tossing 2 coins, sample space, tossing 2 coins, sample space is head and head, head and tail, tail and head, tail and tail, right? So this is the sample space, the total sample space. Now the question is, what is the probability of getting 1 head? Exactly one head. So exactly 1 head. This is exactly 1 head. This is exactly 1 head. So 2 out of 4. Probability of exactly 2 head. Exactly 1 head, sorry. This is exactly 1. Okay, exactly 1 head equals to 2 out of 4, which is again 1/2. What is the probability of getting a 3 while rolling a die of 6 faces? Okay, so what we get when you roll a single die, sample space is we get 1, 2, 3, 4, 5, 6, right? So we get 6 possible cases. And the question is, what is the probability of getting a 3? So how many 3 are there? 1 3 is there, right? So there is 1 3. So sample space is 1, 2, 3, 4, 5, 6. This is the sample space. And there is only one 3. So again, you don't need to write the sample space. I'm just writing for these questions to give you explain you more. So you don't need to write the sample space. You can think and then find out the answers your own. Okay. So there are 1, 3 out of 6 numbers. So 1 out of 6. Probability of getting a 3 equals to 1 out of 6. Okay. Okay, now let's go to the question 7. What is the probability of getting numbers less than 5 while rolling a die? Less than 5. So there are 4 numbers less than 5 when you roll a die. This is again a single die, rolling single die. So which numbers are less than 5? So 1 is less than 5, 2, 3 and 4. So these 4 numbers are less than 5. 5 is not less than 5. 5 is equal to 5. 5 is not less than 5 and it says less than 5. If the question was less than or equals to 5, then we could include 5. But it says just less than 5. So we just take 4 numbers. So the probability of less than 5 is there are 4 numbers out of 6. Now 4 divides 6, you can divide both numbers by 2. So 4 divided 2 is 2 and 6 divided by 2 is 3. So 2/3 is the probability of getting less than 5 numbers. Okay, now here is a diagram for playing cards. In the probability questions, there are some questions related to playing cards. Like it says what is the probability of getting a red card, getting a black card, what is the probability of getting a king or queen. There are many questions that we can create based on playing cards. Okay, so that's why I put this information here. If you are unfamiliar about the playing cards, because I know that some of you know very well about the playing cards and how many numbers of cards in there and what colors and etc. So some of you know it very well and some of you may not. So I write this diagram just for you to give information about the number of cards that you have in a playing card, in a deck of playing card. Okay, so what we have is there are 52 total cards in a deck, and out of 52 there are 26 black cards and 26 red cards, and those black cards are 13 clubs and 13 spades. We get 13 spades, and those red cards are 13 hearts and 13 diamonds. The clubs, there are 13 clubs, so we get ace and 2, 3, 4, 5, 6, 7, 8, 9, 10 and jack, queen and king. Okay, so these 13 cards are from clubs. Okay, so this symbol in the playing card represent clubs. And so you have spades the same way. You have ace and 2, 3, 4, 5, 6, 7, 8, 9, 10 and jack, queen, king, right? And then heart, you have heart and 13 heart and you get 13 diamonds. And in those 13 numbers, those 13 cards, you get these 3 cards called face cards, because you have the jack and queen and king. They have faces in these cards, so we get jack face and a queen face and king face. So these are called the face cards. So 3 of clubs and 3 of spade, 3 of heart and 3 of diamond. So we get a total of 12 face cards. So we have the total of 52 cards and 13 and 13 of each. 26 of black card and 26 of red card and 12 face cards. Okay, now let's see. These questions are from the playing cards, about the playing cards. You see, if you draw if we draw one card randomly from a standard deck of 52 cards, so you draw one card from the 52 cards, what is the probability that the card is a spade? Now, the question is, what is the probability of getting a spade? So, probability of getting a spade. Now you have to count, like how many spades are there. So there are 13 spades, right? So these 13 spades, so we get 13 spades out of 52 total. Okay, so when you draw one card, you get the probability is 13 out of 52, because you can draw any of these 13 cards. So there are 13 possible cases and there are total 52 cards. So total 52 cards, we divide by 52, and the 13 spades, so 13 out of 52. So when you divide this by 13, and both numbers go by 13, so we get 1 out of 4, because 13 times 4 is 52. So 1/4 is the probability of getting a spade. What is the probability of drawing a queen from a well-shuffled pack of cards? So now you have to count the queen. How many queens are there? Okay, so we get how many queens we have? We have 4 queens, right? So queen, these 4 queens of 4 different cards. So probability of queen equals to, there are 4 queens out of 52. So this is 1 divided by 13. Because 52 we divide by 4, you get 13. So 1 out of 13 is the probability of getting queen. If you draw one card from a standard deck of 52 cards, what is the probability that the card is a face card? So now the face card, there are 12 face cards. So probability of face card equals to 12 divided by 52. Now both of these numbers go by 4. So you can divide 12 by 4 is 3. 52 by 4 is 13. 3 out of 13 is the probability of face card. Again, you can write the answer in decimal format, decimal form. You can use calculator to find the answer in decimal. But for these types of question, like you can always write in the fraction, because if you write the answers in fraction, it will be like exact answer. Otherwise, like if you find the decimal number, you may have sometimes like 0.5555552333333, like those are, then you have to round it up or round up. So in that case, it is not considered as exact as these fraction numbers. So I recommend, if you can, I recommend that you put answers in fraction. Okay, but it is not like mandatory that you must put in a fraction. You can put in decimal also. The putting in fraction is a better way to write the better answer. Okay, if you draw one card from 52 cards, what is the probability that the card is a black card? So probability of black card, there are 26 black cards out of 52. 26 out of 52 is 1 out of 2. 1 out of 2, 0.5. What is the probability to draw a red jack? See, red jack. So there are, see, these are the red cards. These two cards, these two cards are red cards, and there are 2 jacks which are red, right? So a heart and diamond. So jack of heart and jack of diamond. These are the 2 red cards. So it says only the red card, right? So red jack card. So there are 2 red jack cards. So probability of red jack equals to, there are 2 red jack out of 52 cards. So 2 out of 52 is 1 out of 26. So this is the probability of getting 2 red jack from the 52 cards. Okay, so this was just the basic questions related to the probability topic. We have many other questions that are related to probability. We will do those questions in the next lecture. In the next lecture, we will have some more questions about getting probability, how to find probability, and we'll do those in the next lecture. So I like to stop here, and you can practice these questions. You can look at some other videos from YouTube or some other place to learn more about probability. Okay, I'll see you in the next lecture video. Okay, bye.